today is we're going to move to step 3 of our design process. So somebody look at step 3 over there under design steps and read for me what it is that you have to do today. For step 3, what do you have to do today? Mauricio, read it.
Evaluate and troubleshoot. Use the infrared lens on the iPad. Take a picture of your cup. Where is it losing heat? What do you need to do to improve the design? Explain below the changes your group will make and why.
Okay, so we are evaluating and troubleshooting. So part of any kind of design process is figuring out what's working and what's not working. So today is going to be your team's chance to make any kind of improvement that you think is needed before we do the actual test tomorrow. Go ahead and put your hands down right now, listen to everything I have to say, and then I'll take questions, okay? So, what we have on the iPad under photo booth is an infrared lens, also called a thermal lens. And what that does is, when you take a picture of something, it's going to come out all sorts of different colors. Because what that lens is showing is the differences in temperature. So some of you took pictures yesterday and you were like, my whole cup is red. Well, here's what these colors mean. Anytime you see a cooler color, something like yellow, something light, that means there's a lower temperature. If you see a darker color, a warmer color, with red being our darkest, warmest color, that means there's the most concentration of heat. One second, just listen and I'll take questions, okay? So, what we want to see, since we're not putting any kind of liquids in our cup yet, when we take a picture, probably what you're going to see is the places that you have the most insulation should probably be our warmest. Because if the insulation is doing its job, it's going to keep that temperature the most consistent. Okay? And that's where we get confused a little bit, because we think warm, we think it's going to cool, it's going to warm up what's inside. What an insulator does is keeps that temperature the same. So if we put ice cold water in our cups, the insulation doesn't mean that it's going to melt it. What the insulation means is if it's doing its job, it's going to keep it consistent. Somebody tell me what consistent means. Consistent. What's consistent mean, Claire?
The same.
The same. So, if I look at this picture, this is just a glass beaker that I put a little bit of water in. Would you say this is a consistent temperature throughout? You're shaking your head, Cam. Why do you say no?
It's both yellow and red.
Okay, so we're seeing here where most of the glass, where the liquid's not touching, is the same because it's all the same material. But we have a little bit of red here, and we have a little bit of yellow, which means that's not very consistent. I want to see consistent. Okay? Yes, Bailey.
Maybe it's because there's water on the outside of the cup, maybe where you spilled it or something. Would that
Could have been.
be something?
Could have been. But remember, if we want our insulator to do its job, we want it to be the same. So here we have one of our, just an example of the paper cup. Somebody tell me what you notice about the paper cup. What do you notice, India?
There's red and yellow.
Okay, so there's red and yellow. So it's mostly the same, but it looks like there's some red here, maybe where the water is. So I wouldn't say that's doing a bad job. That's pretty consistent. But where I see the differences in color, that's going to mean that I'm going to lose some of that heat. So perhaps the paper cup with some more consistent insulation around it would do a better job. All right, let's look at one more. This is the plastic cup. Somebody tell me what you notice. at the bottom. Where else?
The top rim.
Okay, the top rim. So if this is the picture that you got back as a design team, what would be a solution that you could use? What would you want to do to fix this problem so that it would be more consistent throughout? More consistent. And I said, you can have one material to fix this. What would you do?
Oh, you can have extra material.
Well, if I tell you, you have one material to fix this, what are you going to do? As a design team, what are you going to do?
Put them on the wall.
Okay, so Beto says put something on the bottom. So what's something that I'm going to want to use? What do we think? What do we think, Beto? What would be something that you think would be smart to put there?
Like something cold.
Coal?
Like some.
Do we want to put something on? No, just think about it. Think about it. I'm asking you. Leave them alone. Let them think. What's going to be something that's going to work as an insulator?
But like another.
You can say it. Another cup. So another cup, if I would put another cup over top, that's going to provide more insulation. That would work. What else would work? What else would work, McKenna?
Saran wrap.
Saran wrap. That would provide more insulation. Perhaps I want to put some cotton around the cup. So, here's going to be your job today. Bailey, what were you going to
I was
say?
gonna say we can put tinfoil around it because we were taking pictures of our cup yesterday, and everywhere that we didn't put tinfoil, it was getting a little darker color,
Okay.
like more of a red.
So what do you think that foil is going to do? Because we said that metal is actually a conductor. So what would it be doing? What might it do for us, Dylan?
This is aluminum.
It is aluminum,
So that's
which is metal, which is a conductor. We're not trying to conduct, we're trying to insulate. But why would we find that it might work?
It might work using the aluminum foil. It goes through, like, it's a conductor, so.
It would go through, but that's not what we want to happen. So what's something else that aluminum might do for us that could provide us some help with this?
When you put the aluminum over top, the heat that it has, it might lose it. With the aluminum, it might take it up.
Am I what?
The aluminum might take it up and just lose the heat that it already has.
Okay, maybe. What else do we know about something that is metallic? I mean, I see a lot of light in this room. Lots of light. What do we know about metallic objects? We did it when we had those flashlights. What did they do?
Almost happy.
Did they absorb?
No, they.
Yes.
They reflected it. So what might happen whenever all this radiation comes in? What might that foil do? It might reflect it. India had an idea too about conductors. So we don't know for sure, but that is just one of our hypotheses. That's something that we might think about. So here's your group's job today. Each group is going to get one iPad. You are going to be able to take a series of photos, okay? Once you take 3 photos, how many photos?
3.
Great, we're not taking photos all day. We have 3 photos, that is plenty of evidence for us to observe. Then I want you and your group to sit down together and look at that photo and determine what you need to do to make that insulation more consistent. I will offer you 1 new material. How many new materials?
1.
1 new material that you can use to make a change. Now, what if you look at it and you notice that your design is already all red, all one color? Are you going to want to change anything?
No.
We're looking for consistency. If it's all the same color, that means that it's remaining all the same temperature. Do you have to change something?
No.
No. and Y in big capital letters. Yes, India?
If you don't make a change, do you have to?
If you don't make a change, you need to tell me why you're not making a change. Okay, you don't have to. So all in all, this should take us, we have 8 minutes before we go to lunch, and then we will take about 10 minutes after lunch to finish this up. But this shouldn't be something that would take us a long amount of time, okay? Caden, Jesus, Bailey, go ahead and get iPads for your group. Yes. We're doing cold water. We're doing cold water. It's not gonna matter. Come on, later. You don't want to say whether it's cold water. Frankie, go ahead and get an iPad. Dylan, get an iPad. Chris, get an iPad. Madison, get an iPad. Also get your cups. There were iPads. The lid has to be the lid. So they're going to take that off so that there's not a lid. And technically then there's no lid. Gentlemen, from Ms. Hardeman, you know
Look at the bottom though.
Here's your different color. Here's your part of that.
Where's the hot dog?
So it looks like that's your food.
You can't drink out of your
So what do you think? So my question is that holding it at a consistent temperature all the way through? No, so which part is not working well? Okay. Well, obviously, because we're not allowed to have a lid like that, you're going to have some air and things like that. There's nothing we can do about that. And then just take this. No, like this. Remember, you can make it. So what do you think that's going to do?